What do you think will be humanity's most enduring legacy? Do you think it will be our science, our art, or some incredible cultural achievement? Or will it be something more down to earth, like the plastic bag you just threw away, the coffee cup you took to work this morning, or maybe the chicken bones left over from Friday's takeaway? Plastic, cheap clothing, and convenient products are now everywhere in the natural world, and will likely be a signature feature of the geological record for our time on the planet. I'm not gonna lie, that's a tough point to start a podcast on. But is this inevitable? I'm your host, Dr. Russell Moore, and this is IFL Science, The Big Questions. Today I'm joined by Sarah Gabot, a professor of paleontology, and Jan Zalesavich, professor of paleobiology, two researchers from the University of Leicester and the authors of the book Discarded: How Technofossils Will Be Our Ultimate Legacy. They're going to tell us more about how the crap we throw away today will be sticking around long after we're gone, and, more importantly, how there is still time for us to do something about it. Jan and Sarah, thank you so much for joining us today. If you could just quickly introduce who you are and what you do, just so our listeners can know who we're talking to.
Yeah, I'm Professor Sarah Gabot from the University of Leicester, and I am a researcher in paleontology.
And I'm Jan Zalesavich, also at the University of Leicester, emeritus professor, so retired, but still trying to work with rocks and fossils.
So thank you for agreeing to speak to me on this today. I mean, it's a fascinating subject. We were looking to discuss the ideas of the Anthropocene and human impact on the world and geology in particular. And then this seemed like a very novel way of having that kind of broader conversation and talking about something very, very fascinating, which is this idea of technofossils. So I was wondering if you could just quickly introduce our audience to what the idea of a technofossil is.
A technofossil is any man-made material or object that has the potential to become preserved into the far future and become a fossil.
Very kind of straightforward, really, isn't it?
Yeah, so it's incredibly broad, and we can think of different sizes and different materials. So this ranges from everything from, an entire city with skyscrapers and roads and subways and all that kind of thing, all the way through to everything that you're looking at. Maybe if you're sitting at a desk, pens, your mobile phone, all the digital stuff, all the way through to microscopic. So things like microplastics. These would all count as technofossils.
So I was reading through the piece you wrote on the conversation and was surprised to see things like chicken bones mentioned within that. And now that wouldn't strike me because you'd think of that, chickens being an organic product, an organic thing. You wouldn't really think of that in this category as a technofossil. But do you think, does that count as an example of a technofossil because of its peculiarities with the kind of current era?
Yes, chickens absolutely, or at least the standard supermarket chicken, absolutely depends upon technology. It's being created by technology, to be both bigger and weaker as regards bones and its structure than the standard, farmyard chicken or the ancestral chicken. It lives in and is used and is consumed by technology all the way. It wouldn't exist without a very sophisticated technological structure, all around it, so it would not survive, in the wild. Even within technology, it's not designed to live for longer than a few months, compared with the, let's say, 15 years of the ancestral chicken. And it's also paleontologically different, because it has a different bone structure. It is different, from the ancestral chicken and even the archaeological chicken, that, our ancestors in ancient Rome or medieval times, you used to have scratching around the yards. So very much, it is part of, what we call the technosphere.
So yeah, you're right. I mean, it really is a very broad category, isn't it? This the idea of the technofossil, and as you said, it's the everyday implements and things that we have around us that we just take for granted. I mean, most people would think of plastics. Plastics would be probably the most common one we think of. But when I was reading your book, I was struck by just the complexities of a ballpoint pen and how the components in that will have their own life cycle, independent of one another, based on certain conditions and things like this. So it's a very, very broad and very complicated category as well.
Yeah, so if you think about it, as humankind, we've used some materials that have been around for millions and millions of years that are completely natural. So say, for example, wood, that's a material that's natural, but we have configured it in ways that are obviously unnatural. So we make tables and chairs and instruments and violins and all sorts of things from wood. We've also made new materials. Plastic, as you say, is a fantastic example of that. But in fact, we've made many new minerals as well. I think, is it, Jan, 200,000 minerals that we've invented?
It's now approaching 300, or may even have exceeded 300,000 new synthetic inorganic crystalline compounds, as opposed to a little bit more than 5,000 natural minerals on Earth. So it's an enormous, cornucopia, Pandora's box of minerals that we've created.
And we're also doing things like we combine new materials or sometimes old materials in ways that nature just doesn't combine things together. So, for example, glass and plastic and metals in a mobile phone or a laptop or something like that. So, we're making new materials, we're using natural materials in ways that are entirely non-natural, and we're also combining materials to make this amazing diversity of different objects. And all of this is technofossils.
There's also a very time-specific aspect to this, isn't there? So, I mean, you were talking about how many minerals have been created, but the synthesis of those minerals has happened in a very, very short period of time.
Yes, very much so. I mean, the natural minerals on Earth have evolved over 4.5, in fact, over more than nearly 5 billion years, because they include tiny mineral fragments which formed before the sun started, from dust clouds in far outer space. And those have gradually built up, as Earth has become more complicated as a planet over these billions of years. But the recent evolution of synthetic minerals has been much, almost infinitely more rapid than that, to create substances which, don't exist elsewhere in the solar system, and some may not exist elsewhere in the universe.
I mean, the first question I have on the back of this is what kind of got you into looking into this as a subject? I mean, Jan, you're a paleobiologist, and in this area, you're paleontologist. So these are two areas that you wouldn't really usually anticipate as looking forward at future phenomena, very much supposed to be looking behind you. So what created this kind of change of perspective?
That's a great question. So the particular field of paleontology that I investigate is called taphonomy. So this particular area seeks to understand how fossils are formed all the way from immediately after the death of the particular creature that's going to form a fossil, all the way through to it being found by a paleontologist or somebody else millions and millions of years later. And we study taphonomy because it's important to understand how fossils form, because we need to understand which parts of animals, and plants for that matter, but mainly animals, which parts of animals are likely to become part of the fossil record, and which parts of animals are likely to decay away and be lost completely. And that allows us then to kind of read that fossil record with more accuracy, to say, okay, in this ecosystem, are things missing because they just weren't there, or are things missing because they never got fossilized? So that was my route to this, because I was thinking about I was sitting in my office during COVID and thinking about all the stuff around me, and it was a pandemic. These dark thoughts were going through my head, and thinking about what will become a fossil, what will our legacy on the planet be, and that's how I got into it. And then I'm super lucky to have already known Jan, and we've written stuff together before, because obviously Jan is well known for his work on the Anthropocene and his thinking of going forward from this time too.
Yeah. And my involvement is it complemented Sarah's very nicely in that while Sarah has developed this huge expertise on fossils and how they form. I guess my beginning was more general, which was to look at the geology, writ large that humans are creating. And how that compares with the geology of the past. And that includes, things like the kind of sediments that are made. Let's say, how do rivers behave? How do building dams affect the flow of sediment, from the river into the sea and things like that? And that was all part of examining this idea of the Anthropocene, this idea that humans are changing the Earth in a very big way, and in a way that will have repercussions, for thousands and millions of years. So those repercussions are, of course, the look into the future. Probably the most important change, is the change to the living world, to the biosphere. And this is where, fossils and paleontology come in, to try and combine the knowledge, of what is happening geographically, ecologically, environmentally today, with how that is actually affecting, both the living constructions that we make, like chickens, and also all of the non-living items, the ballpoint pens, the mobile phones, the books, the coffee mugs, and all of that. And all of them, can be approached by the kind of, expertise and skills that Sarah has developed.
I mean, it's absolutely fascinating. I mean, we've mentioned the Anthropocene a few times here, and you yourself, Jan, you're involved in the working group.
I'm still involved.
You're still involved, and so how does this work impact your thinking about the Anthropocene and how we categorize our time now? It's a relatively controversial subject, I suppose, in terms of a portion of society not believing in the whole concept at all in any meaningful way, but equally on a kind of official geological record level, or whether or not we are indeed in a unique time period. So how has kind of this informed or come out of that kind of thinking in your side of the work?
I think they inform each other. I think the Anthropocene, forms a context for the kind of detailed studies that Sarah and I are doing, and also the kind of ideas and deductions that we make on technofossils build into the evidence base for the Anthropocene, as a concept, as a new epoch of Earth history, because the Anthropocene is a very new idea. It's only been around for 25 years from the beginning. It's only been looked at seriously geologically, for 15 years. And there's all kinds of new evidence coming in, even as the world is changing around us. And so it is always a struggle to try and bring this evidence together and bring it into focus. And one of the key questions is the Anthropocene a blip or not? Is it just something that's happening now and then, everything will go back to normal, or will its effects persist? One of the take-home points from Sarah's and my work on technofossils is that this fossil record is going to be very big and will persist for a very long time. Indeed, it will interact, with life at the surface, for centuries, millennia, and even millions of years to come.
So there's a kind of, whereas we think about in a biological specimen, a biological fossil, the creature's died and it's been preserved in particular ways, and that's kind of the story done. Yes, there's detailed processes taking place below the surface, but nobody knows it's happening until they see it. Somebody millions of years later is walking along a chalk path and finds something on the ground, whereas these technofossils seem to be something that's going to have more of a posthumous life than biological ones, in that they're going to be interfering and interacting with the surface world in a bit more of a tangible way. Is that correct in that kind of assessment?
I think broadly, yeah. So the big thing about fossilization of normal creatures that we spend our time studying is so they're soft tissues, or things like eyes and muscles and organs and skin. To become preserved, there's various ways of doing it, but they're all natural ways. okay, non-human induced ways. So sometimes the skin or the muscles get replaced by minerals which grow in the water around the fossil. Sometimes mummification takes place and the fossil gets dried out. The same with the bones. If bones become preserved, we have all sorts of ways of doing that, but minerals growing inside the bones is a key way. But this is all natural. This is done by bacteria, this is done by fungi, this is done by other animals, and it's done by natural minerals. So you're quite right that the technofossils that are, well, the discarded items that we are, making and discarding, and, let's be honest, kind of scattered all over the environment today, they are very fossilizable because they're made largely of materials that were designed to last. I mean, think about a plastic water bottle, right? You use it once, you recycle it once or twice, and then, if you're lucky, it gets recycled. Only about 9% of plastic gets recycled. I think it's a bit higher for the plastic water bottle. But in any case, it's designed to last a lot longer than its intended use. So basically with technofossils, it's a kind of different story. And just as Jan said, they're lasting a lot longer and they can interact with the environment longer. But also the important thing is in non-natural ways. Okay, so they're, in breaking down, they're releasing potentially, harmful chemicals and toxins into the environment. And just the physical form of them is not natural, and so it is having a large effect on all sorts of different ecosystems. And to be honest, none of it is good, because this planet evolved life over 3.8 billion years, and all of a sudden, if you imagine, in a blink of an eye, we're completely resetting the stage in a bad way.
And it's a scary subject as well. I mean, as you've just said, the impacts of that are quite broad, and potentially, we do not know in what ways these things are going to come back and haunt us or future generations. How do you find talking to people, the general public, about this subject? I mean, when you start explaining to, you're having a pub lunch with some friends and you're explaining a technofossil to them, how do people respond to this idea? Does it make them uncomfortable? Does it make them curious? Does it make them feel more locally involved in their own responsibility to the environment, anything like that?
I think the perspective it gives, of the far future, is one way that, you can hopefully at least diminish, the scary, worrying, anxious part of it, because you're dealing on this huge time scale. You're thinking of plastics the way we think of the dinosaurs, as something at that perspective. Because of that context, if at least, if the conversation, goes in a relatively sensible direction, you can hopefully think about things more rationally, more abstractly in a way, and perhaps more effectively to simply say, what can we do that will help, practically, in that, having this long-term vision, of both the deep past and the deep future. And it can be used in all kinds of practical ways. I mean, for instance, Sarah has got this, amazing project now, which is dealing practically with technofossils, removing them, in fact, from one of Leicester's most polluted rivers, as part of a local project, including all kinds of community work. And that is one of the ways, and Sarah can tell you more about that. It's a terrific project, but it is one of the practical uses, of paleontology.
Yeah, I think Jan's spot on there about the way that people think about things, because I think people are really surprised about the length of time that things are going to last. The other thing that I will say that happened when Jan and I were researching the book is that, we had to look up and research and get accurate figures for the amount of stuff that we are actually making. And both of us would, talk very regularly, and we were both constantly shocked and surprised about just how much stuff there is, right? So, I mean, there's all sorts of figures, but, you've heard about the minerals, but, clothes, 100 billion garments every single year are made. 22 billion pairs of shoes. It's something like 400 and something million tons of plastic, and plastic is light, per year. And then that's expected to go up to 1 billion tons by 2050. I can't remember what it was for ballpoint pens, but was it something like 200 billion, ballpoint pens? And I guess the big thing, when I'm down the pub with my mates talking, is to tell them some of those figures, and then they are shocked, right? And I think one of the key messages is we need to stop producing so much stuff. That is a massive problem. We are consumer crazy. And this has happened, in a big way since the end of the Second World War. And it's driven, by economics and so on and so forth, which we don't get into in the book, but we do certainly get into the fact that there's just too much of this stuff. And it's accelerating. That's the problem as well. We're accelerating production rates. We're not reducing them.
I mean, I was also staggered by just going through your book, and just in the early, the first few chapters, I was blown away by certain factors. I'd never considered that tea bags are actually laced with plastic. That one was a shock. I've been throwing them on the compost heap for several years, and I think you referred to them as, if you go back and dig that up, you'll have zombie tea bags in there, which I thought was perfect because that is exactly what I end up finding. But the other one was around common statistics around how long plastic might last. Estimates of 400 to 500 years. And you explain that it turns out that was just a kind of a guess an intern made, and it's been proliferated across the world, but has never been kind of dealt with beyond that.
So plastics is very complicated, right? There's all different types, and all different types of plastics are sort of going to behave differently, and there's all sorts of stuff shoved into plastics, and that also has a big impact. But there was a study recently. There's very few studies on actually how long plastic is going to last, because of course we've only had it around for 75 years, maybe 100, so we can't collect samples older than that out there in the world, so we can't see really what happens to it. And then when we do things to it in laboratories to try and simulate plastic degradation, irradiate it with UV light or oxygen and water and so on, nothing happens. So you have to artificially accelerate the conditions, the rate at which it happens, by inflating those conditions, so they're not really environmentally relevant. But Jan and I in the book argue strongly that in certain conditions, we think some plastics in particular will last millions and millions of years. And we have good evidence of this, not because we found plastic that's that old, but people have found these tiny green algae that are microscopic, and they kind of make a little jacket, a little cell wall for themselves that contains a biopolymer. So it's like biologically made, but it is a polymer, and it's almost indistinguishable from polyethylene. And we know that they do this now. We have exactly the same fossil. It looks identical. 48 million years ago, you analyze the little cell walls of that, and it's exactly the same. So basically what we can say is, in those conditions where those cells were basically living 48 million years ago, they got buried quite quickly. They were sort of in the caldera of a volcano in anoxic conditions, so no oxygen. So they didn't get much sunlight, and they didn't get any oxygen, and they survived 48 million years. And those conditions aren't unusual on the planet. All these plastic items that sink to the seafloor, and there's a lot on the seafloor. We think that only 1% of the plastic that they've measured in the oceans is at the surface. That means another 99%. So these horrifying figures mean that more than 99% is actually at the bottom. That is away from sunlight. It's in the cold. It doesn't have much oxygen once it's been buried a few centimeters or feet. And so it's just going to sit there doing nothing. So, yeah.
It's a staggering thought, terrifying thought. Your use, Sarah in particular, you're used to looking back at the distant past and looking at ancient fossils and examples. Imagine if we were geologists of the future looking back at now, or a paleontologist of the future looking at the current situation, or even an unknown alien civilization that's finally come here and is having a little bit of an excavation. What do you think their takeaway interpretation of this era would be?
Well, one impression I think that they'll get is one of almost infinite and highly confusing diversity. If just looking at my room around now, there are many kinds of human-made objects, all different kinds, books and pens and wallets and all that kind of stuff, rulers, bits of electronic gear, clothes, and so on. Far more than there are species outside. In my garden. Of birds or trees or stuff like that. So this immense diversity of stuff, which is evolving very quickly. The way that you get a new generation of mobile phone almost every year now. So and as Sarah said, these things are speeding up. And also in huge amounts, of stuff that we're making, and much of it, I guess it depends whether we're looking, at it from 1,000 years ahead, looked at by humans who are human archaeologists, or 100 million years ahead, looking at some kind of species which is trying to interpret the objects made by a completely different species an aeon ago, in that, and having no cultural contact at all with that, in which case I think there are going to be so many puzzles out there for whoever is going to dig up our remains, to try and interpret what a fossilized guitar might be, or a fossilized metronome, or a toothbrush, or the little recorder I'm using here to make the recording on. It is going to be the world's biggest paleontological puzzle.
Again, in your book, you have examples, you have photos of like impressions you've made in, I'm assuming, clay surfaces, and you've taken everyday objects and just impressed them into them in a way that kind of would give us the impression of what we expect to see with a fossil's imprint. And it was things like, the one that stuck out in my mind was the kind of ear cuticles, and I think a condom and the tampon pressed into that as a form of, visual relief. Again, that kind of hits home the nature of kind of what we're dealing with here. I suppose off the back of that, and then again, it kind of pulls everything, all those features in together of what we've kind of been saying. I mean, what do you think the ethical or philosophical implications of realizing how many of our everyday objects are just going to be turning up in these discernible layers of the Earth's kind of geological record? Is there any like really key problems? I mean, we've highlighted a few of them already in our discussion, but it seems to be some like very central problems that will come from this.
Yeah, I mean, I think the broad message, as well as the sheer number of items that we're making, the fact is that we are using up resources that are fairly precious to make all this stuff. Then and of course there's the whole climate warming scenario as well, that kind of is really part of this as well, and one of the chapters in the book speaks to this more clearly. But there's we're making all this stuff and then it's being discarded with no thought really or plan as to what the long-term future of it is. It's kind of like we just haven't thought about it. And I guess one of the things that we draw on here is that in terms of policy and legislation, radioactive waste has been thought about it. We have thought about radioactive waste because obviously it's very dangerous and we need to know what to do with it for at least 100,000 years plus. And of course, we're still really kicking that ball around the park in this country. Most of our radioactive waste still sits in Sellafield, and we're still scratching our heads a little bit. There is a facility that's now, I think it's opened up in Finland, where there is radioactive waste being put away, which they think is going to be safe for the time that it takes for it to decay. But for all this other stuff, we haven't thought about it. We haven't thought, what is going to happen to all this concrete? What's going to happen to all this plastic? What's going to happen to all the paper? What's going to happen to these materials in the long term? And it's that classic thing that we are with humans. We're very good at getting on and doing and inventing and creating and making our lives easier through creating disposable items. But sometimes we don't stop and think about what the consequences of our actions are.
Yeah, that's exactly right. I think the technofossil idea can help us trying to think through some of these dilemmas, and try and organize our thoughts. One, central question is, how long will it be before all this stuff, which is now at the surface and often being harmful, being toxic, or being, the plastics which are physically eaten, by fish and seabirds and so on, how long will it be before they go through the geological cycle sufficiently to be buried in strata, and then, if you like, to be out of harm's way and safe. That's a very complicated journey, because on the way you can have, let's say, you can have the sediment layers containing these being exhumed and brought to the surface again, by landslides and things like that, and they can re-enter the cycle and start traveling until eventually, they will be, form part of far future geology and be, then, if you like, an abstract interest rather than, a problem for us and our children and grandchildren. So working out, if you like, the passage of technofossils, through the Earth system and through the geological cycle, I think is one of the big questions. And we're only just beginning to think through, this kind of problem.
Mm-hmm. I mean, the start of your book, you refer to it as the start of effectively kind of a new age and a new adventure for our species in many ways. When we talk about the Anthropocene, climate change and these types of issues, obviously there's worries and there's concerns. But I got the sense in your book and also in your conversational piece that you talk about it in quite a upbeat way. Not in a way that minimizes the impacts of that, but there's not a tone there that is terrified or existentially concerned or heavy. How do you feel about the kind of the future challenges and our perspective and the perspective of us as a species being able to kind of rectify meaningfully the legacy we're leaving behind?
Okay, well, I think we have to try and treat it, if you like, seriously, of course, and think it through. But also it does not help, if one is forever, anxious, terrified, petrified, by this kind of thing. It is part of life's grand adventure, and adventure does include both, tragedy as well as the good times in life. And we have to deal with it, as best and honestly and clearly as we can. So, to have some element of detachment and some element of saying, this is really interesting stuff, as well as it's really serious and potentially damaging stuff. But it's the interest, and the puzzle aspect that helps keep us going and keeps us trying to do useful work and get useful ideas, on all of this.
Yeah, because the bottom line is that as we wrote and spoke about the book and the various chapters and the various objects and technofossils and so on, we realised that actually we know so little about all this stuff and how long it's going to last and what journeys it's going to take between, being a discarded item and then becoming a final part of the, the geological realm, if you like, and, taken away from interactions with us. And, it's kind of a new branch of science, right? It's like the taphonomy of stuff that we have made. So if we appear upbeat, I think it's in part because I think we are saying that we need to understand this stuff more. And to do that, we need to do the hard science, to do the research, to do the experiments in laboratories, to collect the samples in the field, work with materials scientists, chemists, geologists. This needs a kind of multi-directional approach to understanding it. Myself, I flip-flop every day virtually as to how optimistic or not I feel about our species. And so some days when I'm working down the river and I'm cleaning it up and I see all the junk that people have put in the river, and I'm not just talking about, plastic bags and so on. I'm talking about hoovers and computers and carpets and mattresses and sofas and TVs and all that kind of stuff, literally just chucked in the river. Then I kind of get depressed. But then I work with groups of people who get really stuck in and they work all day. And I work with a lot of ex-offenders to do this work. And they get it, right? And they work really, really hard. And so I go from being really utterly depressed to really, optimistic about us as a species. But I do flip-flop, I'll be honest.
Understandable.
I think we've covered a fair bit of ground. I can't.
Yeah.
There are some. Obviously take-home messages. Try and think it through. Broadly. Next time you go shopping. Be careful. So let's try and stamp out technofossils. Slowly and gradationally. But yeah. I mean, as I say, it is a grand new area. of science where, which can give, we hope, practical help, in cleaning up the world of all this junk, or at least being able to cope with it, more sensibly.
Thank you. And I think our listeners are expecting to just talk about, some of the detritus we're leaving behind, but we also got some very strong philosophy on how to deal with the future. So thank you very much, both of you, for your time.
That's great. Many thanks for your interest in all of this, future fossil stuff.
Thank you.
See you. Bye.
The music in this episode is credited to Audio Blocks.